First of all, imagine you had tiles of these colors. One side is yellow and represents positive 1. The other side is red and represents negative 1. We would also have rectangles where one side is green and represents positive x, and one side is red and represents negative x. So using this key, let's model 2x plus 3. So if I want x terms, I'm going to need rectangles, and if it's two positives, I need two greens. To show the whole number plus 3, that's going to be positive 3, so I need 3 little yellows, just like that. So notice we are now modeling 2 x's and 3 1's, which is 2x plus 3. Now think about how you would model negative 5 plus 4x. If you said we need red tiles now, you're correct. For 5 negative, we need 5 little red squares. And to show positive 4x or plus 4x, we're going to need 4 green rectangles. Just like that. Now let's model 3x minus 5. 3x minus 5. First of all, 3x would just be 3 green rectangles, and minus 5 is the same thing as adding on negative 5. So notice this says minus 5, and I've got 5 red tiles because negative 5 is the same thing as minus 5. Next, it's your turn to write an expression to represent this model. Did you decide that positive 3 yellows equals the whole number 3 and 4 red rectangles represents negative 4x? When we put that together as an expression, there's a few ways that it could look. You could have 3 minus 4x because minus 4x is the same as negative 4x. You could also have the x term in front, negative 4x, and then plus 3 for the positive 3. Or you could have 3 plus negative 4x. All of these three mean the same thing. Now let's take it one step further. What if we were to model 3x plus 6 plus 2x? Well, here we are. We have 3 x's and 6 1's and 2 more x's. But can't we rewrite this? Do you see anything that is alike that could be combined? Watch this. Ooh, magic. So when I put together the things that are alike, you can see really when I put 3 x's with 2 more x's, it's really 5 x's and 6 1's separately. But what I cannot do is put it all together and say I have 5, 6, 7, 8, 9, 10, 11. I can't say that I have 11 x's because I don't. They're different. I have 5 x's separate from 6 1's. Now let's look at this one. 2x minus 4 plus 1x. If we were to model it straightforward, it would look like this, but let's rewrite it. What can be combined? If you said 2x and 1x, you're right. Watch this. Oh, look at that. We're going to combine things that are alike to simplify our expression, because saying 3x is simpler than saying 2x over here and 1x over there. It's really just 3 x's all together. What I cannot do is combine 3 with negative 4 and say, hey, there's negative 1 or negative 1x. No, that would not be true because these are not alike. They are different. I cannot combine them. I have 3 of one type and 4 of another type. So 3x minus 4 is as simplified as this expression can get. Okay, what about this one? How would you model this? All right, so this time what can we combine? This time there are no extra x's to combine, but we do have numbers that can be combined. We have 4 negatives on the left and 3 negatives on the right, and if I put them together, I have 7 negatives. Okay, so I still have 5 x's and negative 7, so we can write 5x minus 7 for its simplest form. All right, now we've got negative 3 minus 2x plus 5. Let's model it. Ooh, now this one's interesting. What happens when I put a negative with a positive? If you said 0 pair, you are right. They zero each other out. They cancel. So let's see how many 0 pairs we have. There's 1, 2, and 3 0 pairs cancel each other out. So what we have left is 2 positives. We have 2 positives here. And also the 2 negative x's. All right, let's look at the next one. 2x plus 6 minus 3x. Let's first model. Okay, what can be combined this time? All right, let's put these 2 x's with those 3 negative x's. They are alike in that they're both rectangles and some of them cancel each other out. Go ahead and think about what that will give you. Oh, it gives us only 1 negative x remaining. And when we have one of a variable, we do not have to write the 1 in front of it. So this negative x is the same as saying negative 1x. And I still have positive 6 ones separately. What I don't have is 7 rectangles, so I can't say 7x or 5 if I were to do the math. So we have to keep them separate. X's are different than 1's. All right, guys, good job today. So what we just did was we simplified expressions by combining like terms. And when you do that, remember, they're only alike if they have the same letter, the same variable. Or you could also combine numbers with more numbers. What you cannot do is put x terms with number terms because they are different. Thanks so much.